Boom, here we go. All right. So, y'all, 6.3 talks again about confidence intervals for something we call population proportions. So, y'all, in this section, we're going to learn how to construct a confidence interval for population proportion or probability of success known as P. The process is going to be very similar to what we've been doing for confidence intervals for the population means. And what we're going to do is we're going to start with a point estimate. So the point estimate, y'all, is a population of proportion of successes given by the proportion of successes in a sample and is denoted by, and there's a little symbol here, y'all. So let me tell you what this means. That little P with a little arrow on top, y'all, we call that P hat, okay? And it's going to be X divided by N. I'm going to tell you what all that stuff means in a minute. And then if that's my proportion for the successes, y'all, we're also going to have a proportion for the failures. Q hat. Q hat's going to be 1 minus P hat, okay? So we're going to go through this, y'all. The first question, we're going to try to make it really easy breezy cover girl here, okay? So it says, in a survey of 883 American adults, 380 people said their favorite sport was football. Find a point estimate for the population proportion of adults who say that their favorite sport happens to be football. Okay. So, y'all, what we're going to look for here, we're going to look for that number that we're calling P hat. Okay. Now, in order for us to find P hat, y'all, we got to find a couple of things. We got to know what's our number N and what's our number X. N, y'all, is the total number of individuals we surveyed. So if I look back to this question, y'all, we surveyed 883 people, okay? And out of those 883, do y'all agree 380 were the ones that selected football as their favorite? Okay, so look, y'all, I'm going to turn on my calculator real quick. Sorry. Let me turn on my calculator real quick. Let me clear everything out. And y'all, I'm just going to divide this out. 380 divided by 883. Okay, so y'all, usually for these kind of questions, they usually ask us to go to like, say, 3 decimal places. So y'all, I'm coming up with 0.43, I guess? All right. All right, now y'all, I know it's not necessarily part of the question right now, but we're gonna use it in a minute. So I'd like for us to find Q hat. Q hat, y'all, is gonna be the people who did not select football, okay? So there's a couple of ways we can do it. The easiest way, y'all, we can find Q hat is just to take 1 minus P hat. So 1 minus 0.430, right? So we're going to go 1 minus 0.430, and I'm coming up with 0.57. Okay. That's the easiest way you can do it. The other way you can do it, y'all, not as easy. I mean, it's not necessarily difficult, but remember, we can do it like this. We surveyed 883 people, right? The number of people who said they liked football was 380. So how many didn't? 503, right? Look, y'all, if I take 503 and I divide it by 883, boom. If I round it again, 3 decimal places, wouldn't it be 0.570? Yeah, it's the same thing, right? It's just another way you can go about doing it, okay? So, y'all, we're going to figure out how to find confidence intervals for population proportions, okay? Just like we did before, y'all, we're first going to figure out how to find the error, okay? Now, y'all, just like I did before when we did 6.1 and 6.2, I'm going to come back to that question in a minute. I'm actually going to do question number 2 right here, okay? So question number 2 says, can we find a 95% confidence interval for the population proportion of American adults who say that their favorite sport happens to be football? Okay, so the first thing we're going to do, y'all, 95%. I'm going to draw my normal curve, okay? Just to remind everybody, hey, what does a 95% confidence interval look like? It tells me, my friends, that the area in the middle is going to be equal to 0.95, okay? Now, y'all, what we're going to do here is we're going to find that critical value, that ZC score, right? So let's think about it this way, y'all. Remember, if 95% of the area is in the middle, that means 0.05 I got to divide that by 2. That's what's going to go in those 2 spots, right? And if you're wondering, hey, Omar, how'd you get 0.05? Remember, y'all, 1 minus 0.95, 0.05. That's telling me that's going to be the area in those 2 pieces. And because it's 2 pieces, I got to cut it in half, okay? So look, y'all, let's see if we can figure that out. 0.05, let's divide that by 2, 0.025. So right here, y'all, that's a 0.025. So, y'all, just like we did before, we're going to go ahead and use our standard normal curve to do this. When we want to find what is that critical score going to be, y'all, I'm going to go to second, I'm going to go to VARS, and I'm going to use my inverse norm, okay? And we know that the area to the left here, y'all, is 0.025. So, y'all, I know that when I'm going to get my number here, it's going to be a negative number. We're going to use the positive one, right? So take a look, y'all. I'm coming up with negative 1.96, right? So that number right there, negative 1.96. So this one, y'all, obviously just a positive 1.96, right? Sorry, I didn't leave enough space there, y'all. That was my mistake. Okay. Now, what we're going to do here, y'all, is we're now going to find the error. Okay. So look, y'all, I'm going to just write this here on the side. The first thing says we want to use that critical value. What critical value? Oh, the one that's 1.96. Okay. Now, right next to that, y'all, I'm going to write a big old square root. Okay. And we're going to fill in those 2 numbers, y'all. The first one is going to be p hat and, excuse me, and q hat. So look, y'all, my p hat number when we did this earlier was 0.430. Our q hat, y'all, that we did right after that was 0.570. And we're going to divide this by the number n. So y'all, right now when we did our first problem, remember the n was the total number of individuals we surveyed. That was 883, okay? So y'all, one thing I want to emphasize here, I'm going to do this again with the big old marker, boom, like that. All of that business right there, y'all, is going to be inside my square root. The only thing that's not inside my square root, y'all, is the 1.96. So look, let's clear this out. And I'm going to enter this in, y'all, just like I see it, 1.96. And then I'm going to go big old square root. Boom, there it is. I know it doesn't look that big, but trust me, it is. 0.430, okay, close the parentheses, times, we're going to go again, 0.570, okay, we're going to do that, close that again, divided by 883. Okay, now, y'all, I want to make sure that everything is inside that square root, so I'll tell you what I'm going to do. Oops. Right here, y'all, I'm going to insert right there. Boom. Another parenthesis right here. And I'm going to throw one all the way over here at the end. And this is telling me, look, everything is inside that square root, okay? Look, we're going to hit enter. And y'all, I'm not getting a big number, right? Again, if I go to 3 decimal places, y'all, what do you think? 0.032 or 33? 33, right? Okay, so look, our error, y'all, is 0.033, okay? Now, how do we find our confidence interval? The way we're going to find our confidence interval, y'all, right here. We're going to take p hat minus the error and p hat plus the error. So our p hat, we said, was 0.430 minus 0.033, and then, 0.430 plus 33, okay? So look, let's see what those numbers add up to. 0.430 minus 0.033. My first number, y'all, 0.397. Okay. My second number, 0.430 plus 0.033, 0.463. Boom. And there's my confidence interval. Okay. Y'all, if you remember back from last week when we did 6.1 and we did 6.2, I'm always going to show you one problem, y'all, on how to do it manually. Not because I'm opposed to the calculator. Guys, I love the calculator, okay? And one thing, I don't know if those of you who are using the calculator app, let me come back here. And when we did the problem earlier, which was what was it, like 380, 380, right? Divided by, what was it, 883. Y'all, a lot of times, at least on my calculator app, when I do it on my iPad or whatever, on my phone, it gives me the fraction, right? And if you want to convert it to a decimal, y'all, hit the math button, go to number 2, hit that, and it'll give you as a decimal. Obviously, on this calculator, it gives it to me as a decimal already. But I know a lot of times on the calculator app, it gives it to you as a fraction, but that's how you convert it to a decimal, just in case you didn't know. But I always try to show you guys one problem, y'all, where we do it manually, just so that we don't forget what is it that we're trying to find. We're looking, sorry, that's not what I wanted to do. There we go. When we're making that confidence interval, we're looking for those bounds so that the area on the inside is 0.95, right? That's what we're really trying to find here, okay? But there's obviously a way we can do this using our calculator, y'all. And we're going to do that over here with these next couple of problems, okay? So look, let me walk you through a question here, y'all. And this is what we're going to do. So here is my next question. And it says, in a survey of 2007 adults, y'all, right here, I'm going to stop. And what I'm going to do is I'm going to say, look, my N is the number 2007, because that's the number of people we asked, right? It said that 708 of them, that's my X, y'all. 708 of them said that their New Year's resolution was, we're going to eat healthier. So what we're going to do, y'all, we're going to find a 90% confidence interval for that population proportion, okay? Now, y'all, there's going to be a real easy breezy cover go way to do this on my calculator. Let me clear everything out. I'm going to go to stat. I'm going to go to tests, and I'm going to look for a 1 proportion Z interval. In my calculator, guys, it's the one that has the letter A, but it's this one here, 1 proportion Z interval, okay? I'm going to hit that right there. Okay, so let's do this. Look, y'all, it's asking me for my X number. Our X number, we said, was 708, okay? It's asking me for my N number. Oh, you know what? My N was 2007. And we're going to do this, y'all, for 90% confidence level. So right here, my friends, I'm going to go 0.90. And I'm going to go down to calculate, and I'm going to hit enter. And, y'all, it is telling me in this problem to go ahead and go to 3 decimal places. So, look, y'all, I'm going to write 0.335 and 0.370. Oops. Oh, come on, pen. Boom. And there's my confidence interval for the 90%. Okay. Y'all, I want to show you something else. When I do this here, look, it also gives me my p hat. Tells me my p hat here, y'all, was 0.35. I guess 3 if I was going to go to 3 decimal places. But it tells that for me as well. Okay. Now, y'all, we're going to do the same process all over again. Now, the only thing we're going to do, we're going to change our confidence interval to 95%. Okay. So look, I'm going to come back to stat. I'm going to go back to test. I'm going to scroll down to the 1 proportion Z interval. It's and at least in my calculator, it's A. I don't know how it is on yours, but it's on A. It's on mine. Okay. Everything here, y'all, is going to stay the same with one exception. My confidence level now, my friends, is 0.95, right? So look, I'm just going to come right here, go 0.95. Boom. Let's calculate this guy. Boom. All righty. So let's see. Y'all, again, we are going to 3 decimal places. It looks like we're going to have 0.332 and 0.374. 0.332 and 0.374. Okay, so y'all, let me ask you a question. Well, let's actually look at this next part. It says, within the given confidence, it can be said. Now, y'all, there's going to be a little drop-down menu here, right? What are we talking about? Y'all, we are talking about something that we call, oops. Oh, come on. We're talking about something that we call our population proportion, okay? Because look right here, it tells me that population proportion, okay? Of adults who said they have made a New Year's resolution to eat healthier is going to be, right here, y'all, we're going to say between the endpoints. Okay, it's going to be a little drop-down menu. Okay, so it's going to be a little bit of a drop-down menu. Now, the question says, y'all, which one is going to be wider? Y'all, just as a reminder, the one that has the bigger percentage is always going to be the wider one. So which one's going to be wider? The 95%. Okay. The 95%, because y'all, that interval is going to be more, right? The first one only has 90% of the people, right? This one now has 95. So it's going to be even bigger. So always, whichever one is the higher percent confidence level, that's always going to be the wider one. Okay. All right. Let me keep going, y'all. Let's scroll down a little further and let's see what we got here. It says in a survey of 2,658 adults, 1,445 had said they started paying bills online last year. All right, let's see if we can do this again, y'all. I'm going to come back here to my calculator. Let me clear this out. Let's go to stat. Let's go to tests. Let's scroll down to part A, 1 proportion Z interval. Okay, so y'all, again, before I get started, remember, y'all, this is my N, 2,658. And my X is the 1445, okay? So first thing I'm going to do, I'm going to say, look, my X is now 1445, boom. My N, my friends, is my 2658, okay? And we're looking to build a 99% confidence level, y'all. So 0.99, let's calculate this guy. Boom. All right, so look, y'all, again, they're asking me to go to 3 decimal places. What do you think, 0.518 or 519? 519, right? Yeah. So look, y'all, 0.519 all the way to, what do you think, 0.568 or 569? 569, right? Awesome, y'all. 0.569. Okay. Now, we're going to go back here and we're going to say, okay, what are we talking about again? I don't know if y'all guys remember this from like elementary school, right? They would say, hey, look, when you're reading something, you're looking for context clues, right? Remember that back in the day? Maybe even junior high? Look, population proportion. So I'm going to come back here and say, hey, look, boom, population proportion. With 99% confidence, it can be said that our population proportion who have said that they're started paying bills online is between those endpoints, right? So that's what I'm looking for there, right? There we go. All right. So again, y'all, I mean, we could do this manually, but again, why, right? We're going to use the technology because it's going to make it easier for us to go through this stuff, okay? Y'all, we just got a couple more questions to do, and we will be done with 6.3. It's kind of a short section, y'all. And it says, as one way to improve the precision of an estimate without decreasing the level of confidence is to increase the sample size. Okay, but how large of a sample size is needed to guarantee a certain level of confidence? We have a little formula right here, okay? So this is going to tell me how many people do we need to survey so that we can get that confidence level, okay? So it says N equals P hat times Q hat times, and then in parentheses are ZC value divided by the error, all that's going to be squared. Now it says, assuming that we have point estimates. So assuming we know what our P hat and our Q hat is, but if we don't, we're going to use P hat and Q hat to both be 0.5. Okay, so look, let's see if we can run through this question, y'all, and hopefully make some sense out of it, okay? So first thing I start reading, it says, a researcher wants to estimate with a 90% confidence. Okay, y'all, I'm going to stop right there. The reason I'm going to stop right there, y'all, is I'm going to draw this picture. Boom. Here's my normal curve. Okay. The area on the inside, y'all, is 0.90. Does anybody know what is going to be the area in the red? So remember, if we want to find the area in the red, we'd say, look, we're going to go 1 minus 0.90. That'd be 0.10, right? But then we got to divide it by 2. Wouldn't that be 0.05? And that would be 0.05? Okay, look, y'all, let's find those critical values. Remember, the first one I'm going to find, y'all, will be the negative one, and it'll be real easy, breezy cover girl for us to find the positive one. Okay, so look, let's come back over here. Let's go second vars. We're going to go to inverse norm, which is my number 3. I'm going to type in 0.05. I'm going to close that off. Negative 1.64. So we want the positive one, positive 1.64. Okay. So, y'all, before I even read, not even the full sentence, this right here told me, let's find that number. Okay. It says the population proportion of likely U.S. voters who think Congress is doing a good or excellent job. Her estimate must be within 2% of the true proportion. Okay, so the next thing, y'all, this part right here, the estimate, that is telling me my error. 2%, y'all, is the same thing as 0.02 as a decimal, okay? Now, let's see if we can figure out, y'all, part A. Part A says, what is the minimum sample size, assuming no prior information is available? Okay, look, y'all, I'm going to back up a little bit because, y'all, I'm going to use this formula, boom, right there, okay? So look, we're going to go like this. N equals, y'all, if we don't have any information, we're supposed to assume that our P hat and our Q hat, y'all, are both going to be 0.5, okay? So look, the formula says P hat, Q hat, and then in parentheses, my ZC value divided by the error all squared. So my P hat, we're going to put 0.05. My Q hat, we're also going to go 0.05. Our ZC value, y'all, we just got that to be 1.64 divided by the error, which we said was 0.02, and we're going to square all that stuff. Okay, so how am I going to enter this in my calculator? Exactly the way I wrote it. I'm sorry, guys. I made a little small boo-boo here. I put my decimal in the wrong spot. Right here, 0.5. 0.5. The 0 was in front. Sorry. Okay, so look, y'all. The way I'm going to do this is exactly the way I wrote it down. 0.5. Boom. 0.5 again. Okay. And then parentheses, we're going to go 1.64 divided by 0.02. We're going to close that off, and then we got to square it. Okay. Now, look, y'all, we're going to hit enter. And my friends, I'm coming up with 1681. So look what it says. Round up to the nearest whole number. Well, y'all, we already got our nearest whole number, 1681. Okay. All right. Now, excuse me, let's see if we can go through part B. In part B, it says, what is the minimum sample size needed using a prior study that found that 44% of the respondents think that Congress is doing a good or excellent job? Y'all, what this is telling me now, 44% is the same thing as 0.44, okay? Now, y'all, we also need to find our Q hat. Remember, the way we find our Q hat is we're going to do 1 minus 0.44, which should give us 0.56. Okay. Now, to go ahead and find my value of N, y'all, we're going to take P hat, which is 0.44, times Q hat, which is 0.56, and then the rest of it, y'all, will still be the same. 1.64 divided by 0.2, boom, we're going to square that guy, okay? So the only change we're making, y'all, is those first two numbers, okay? So look, 0.44 times 0.56, okay, times 1.64 divided by 0.02, okay, square it, and hit enter. Okay, so look, y'all, remember, we're going to round up to the nearest whole number. So if it says 1656, y'all, I want to mention something. We're always going to round up. So I know it's 0.7 or 0.8, so we're going to say 1657. But even if this had been like a 0.01, we're still going to round it up, okay? So 1657 is what we're coming up with here. Okay. 1657. All right. Now, we're going to look at those two numbers. Which number is bigger? The answer in part A or the answer in part B? What do you guys think? Which number ended up being a bigger number? The answer in A or the answer in B? The red or the purple? Anybody know? This was 81 and 1657. Which one was bigger? Wouldn't it A? Right? Okay. So let's take a look. Now let's answer part C because we know A was bigger. Let's take a look at each of the choices. Having a population proportion raises the minimum sample. So guys, in the first one, we didn't know. So we used 0.5 and 0.5. In part B, they gave us a value of p hat, 0.54. So we were able to find our q hat, which is 0.56. Did that number go up from here to here? Did we go up or did we go down? We went down. So y'all, if it goes down, that means it's doing what? It's reducing the size, right? So it's reducing the size there, y'all. That's really all we're looking at, okay? So if we don't have a point estimate, my minimum sample size is going to be bigger. But once we find a point estimate, it should reduce it down, okay? It should. All right, y'all, I'm going to scroll down a little bit further down the list, and let's take a look at this next one. I'm going to go through it, y'all, the same exact way we've been doing the other questions, okay? So look, let's go really slow here just to make sure that we're all good, y'all. It says a researcher wishes to estimate with 95% confidence. Look, y'all, I'm going to stop right there. I'm going to draw my normal curve, okay? The area, y'all, in the middle is 0.95, right? We want to find the area in the blue. So look, we're going to go 1 minus 0.95. That should be 0.05. But we got to cut it in half, right? 0.05 divided by 2, 0.025. So that's that area. Boom, and that's that area. Now remember, y'all, we're going to have two values. One of them is going to be negative. We are going to look for the positive one, okay? So first thing I'm going to do, y'all, I'm going to clear my calculator. I'm going to go to second in VARs. I'm going to go to my step number 3, my inverse norm. I'm going to type in 0.025. Let's close that up. Okay, so look, y'all, it looks like I'm getting a negative 1.96. So we want to use a positive 1.96, right? Okay, so now let's keep reading the problem. It says a researcher wishes to estimate with 95% confidence the population proportion of families who eat fast food at least once a week. It says the estimate must be between or within 2% of the population. So y'all, first thing about my error, it's got to be 0.02. Can't be more than that. Okay, so look, y'all, when I'm going to do my part A here, I'm going to use our formula. Okay, the formula for N is P hat Q hat times our ZC value divided by the error all squared. Since we don't have any prior information, y'all, my P hat, my Q hat are both going to be 0.5. So look, 0.5, 0.5. My ZC score is a 1.96 divided by 0.02. We're going to square that. Okay. So look, let's see what we get. We're going to go 0.5 times 0.5 times, let me do this part at least in parentheses, 1.96 divided by 0.02. Let's close that off. Let's square it. Let's see what we end up with. 2401. Nice and pretty. So I'm going to write it here in big letters so we can see it. Okay. Okay. Now let's try part B. It says, what's the minimum sample size needed? Using a prior study that found that 36%. Okay, so look, y'all, that's telling me that my P hat is a 0.36. My Q hat, y'all, is going to be 1 minus P hat. So 1 minus 0.36, y'all, should be something like 0.64. Okay. So look, y'all, I'm going to do the same thing. I'm going to write down my formula again. P hat, Q hat, ZC over the error squared. We're now using our P hat to be a 0.36, our Q hat to be a 0.64. I got a 1.96 here, y'all, with a 0.02. Boom, and that's being squared. Okay. Let's see if we can find that one. So let me clear all this business. 0.36, 0.64, 1.96 divided by 0.02. And I'm going to square that. I'm just making sure. Y'all, the one thing I always tell my students, and I know I've said it before, but I probably hadn't said it in a little while. When you're doing these kind of calculations, right? Like I've asked you, what's 3 times 5? And you get your calculator and you see 15, like, yeah, I knew that, right? But if you were to say, what's 3 times 5? And you do it on your calculator, and all of a sudden you see -2. Like, that's not right. I made a mistake. When you're doing something like this, y'all, with these kind of numbers, right? Like, what answer am I going to get? I got no idea. There it is, 212, 213, or I'm sorry, 2212. We're going to round it up, 2213, right? What I'm saying, though, is I want you just to be a little careful when you're doing your calculations. Make sure you're typing in everything correctly, because one small mistake is going to go throw the whole thing off, and it's kind of hard to determine, hey, is my number right or wrong, okay? Okay, so let's take a look, y'all. Did our number, just like we did before, did my number from here, did that number go up or did that number go down? What do you think? From 2401 to 2213, did it go up or down? It went down, right? So look what we're going to say. Having an estimate of the proportion is going to, again, y'all, reduce the size of the minimum sample, right? And I believe, y'all, that is 6.3. Okay. I'm sorry? Oh, yeah, we had one more. That's right. We had one more. My bad. You're right. Absolutely right. My mistake. Where is it? Up here. Yes, you're absolutely correct. Right here. Okay, so look, y'all, we did this. Every time we were doing 6.1 and 6.2, I always kind of save this question for the end. The reason I save it for the end, y'all, I think it's like it usually, at least the last 2 times, it was kind of an easy breezy cover girl problem. And I'm hoping it's going to be the same way here too. So look, y'all, we want to find our confidence interval and our sample proportion. So y'all, this is what we're going to do first. We're going to find our p hat, okay? The way we're going to find our p hat, y'all, we're going to add those 2 endpoints. So 0.628 and 0.658, we're going to add those numbers together. So 0.628 plus 0.658, 1.286. And now, y'all, we're going to divide it by 2. Let's divide it by 2, 0.643. Okay, so here is my p hat, 0.643. Okay. Now, last part, y'all, the way we're going to find our error, there's a couple of ways you can do it. First, you're going to decide which one of those 2 numbers you're going to use. I don't know why, y'all. I always go with that one. I always go with the bigger one. But I'm going to say, look, let's take 0.658 and we're going to subtract our p hat, which was 0.643. So 0.658 minus 0.643, 0.015. And our error, y'all, is 0.015. Boom. And we were able to find our p hat, and we were able to find our error. And y'all, if you remember, I know it's been a week, but we did the same thing, y'all, in 6.1, and we did the same thing in 6.2. When you're given that confidence interval, add the 2 endpoints, divide by 2. That told us in 6.1 and 6.2, that told us the population mean. And then we found the error the same way. We're doing the same thing, y'all, with the population proportion thing here too, okay? All right, so y'all, just to give you guys a heads up, we really got about one more chapter to do, y'all, before the semester is up. Chapter 7. In Chapter 7, we're going to figure out how do we use confidence intervals. And we're going to be doing something called hypothesis testing, okay? So y'all, starting next week, we're gonna start chapter 7 next week. I'm gonna try to keep it, y'all, as simple as possible, okay? And y'all, we're gonna have a third test. Our third test will be over to chapters 6 and 7. So far, has chapter 6 been okay? Not too difficult, easy breezy cover girl, right? Okay, awesome. Guys, my plan is I hope that we find chapter 7 as just as easy, okay? I'm gonna try to keep it real simple for you guys. We might do one section in chapter 8 if we have time. But if we don't, that's okay too. Okay. But we just got a little bit more to go, y'all. And then our semester will be over. Look, we're April the 3rd, right? I don't know if you guys know this or not, but our semester is officially over like this week, the first week in May, because this week is a week of finals. So we got like a month left. You know what I mean? And I don't know if you guys know this or not, but 2 weeks from the day, on the 17th, there's no school. Okay. And you're like, what do you mean there's no school? Check it out, y'all. Look, I'm going to show you guys in case you don't believe me. Look, boom. Let's go here. Let's go to SGC. It's what they call the semester break. So look, y'all, if I go to my academic calendar for 2025, April 17th through the 20th, the college is closed for a semester break. You get a few more days off. So I don't know if you guys remember the first week of school. Wasn't it really, really cold? And we didn't have school that Tuesday, but that was because it was really, really cold, right? But school always starts on a Tuesday, okay? We were off that day because it was ridiculously cold. So the Monday, Wednesday folks already had a day off because school was already canceled for that day. We ended up, we got, I don't know if you want to call it lucky or not, but we ended up having a day off because of the freeze. But since the Monday, Wednesday classes already had a day off, this is how they compensate for the Tuesday, Thursday folks to get a day off, right? So if you think about the fall semester, when we started back like in August, right, we went to school a week or two and then boom, we had Labor Day, right? So you're off Monday. And then the next break, y'all, didn't come until Thanksgiving. And what days do we get off for Thanksgiving? Thursday, Friday, right? It's sort of the same idea. Does that make sense? Okay. So anyway, in a couple of weeks, guys, we won't have class, but again, just kind of giving you a heads up. So next week we'll meet the next Tuesday. We'll do stuff here, you know what I mean? But we're pretty much kind of winding down already, okay? Anyway, that is it for us today, guys. Thank you all for showing up. Again, if anybody needs any help with anything, guys, please let me know. I'm going to go ahead and stop recording. Boom. Right.